At the quantum level, particles are entirely unpredictable. This strange behavior often leads to a profound philosophical dilemma. If the microscopic building blocks of our universe are uncertain, perhaps reality is just a simulation. But the universe is not bound by our philosophical doubts. It operates on absolute, unforgiving physical laws, whether we are here to observe them or not. To understand these laws, we have to let go of our basic human intuition. Take our concept of an empty room. We assume that if we remove all the air, dust, and light, we are left with a perfect vacuum, a space containing absolutely nothing. We also assume that matter can always be broken down. If you apply enough force to an object, it eventually shatters into smaller and smaller pieces. Both of these assumptions are wrong. To see the actual architecture of our universe, we must look at the undeniable weight of empty space and the indestructible nature of matter. In the 1920s, observations of the night sky revealed that distant galaxies are moving away from us. The universe is actively expanding. Decades later, modern space telescopes confirmed that this expansion is actually accelerating. Galaxies are being pushed apart by an invisible force. The source of this push is the space between the galaxies itself. Quantum mechanics dictates that a true vacuum is never completely empty. It possesses a baseline level of energy, constantly fluctuating in the dark. According to Einstein's equation, $E equals mc, $2, energy and mass are permanently linked. If a vacuum holds energy, it must have mass. In a hydrogen atom, the electron closest to the nucleus is forced into a tight space, constantly interacting with the quantum vacuum. This causes a vacuum shake. This friction creates a measurable increase in energy the void is physically pressing against the atom. By combining these microscopic observations with measurements of the entire cosmos, physicists calculated the exact density of this emptiness. 1 cubic meter of deep space weighs roughly $6 times 10 negative $27 kilograms. True nothingness is a physical impossibility. What we perceive as a vast void is actually a heavy, boiling ocean of energy shaping the cosmos. If the void cannot be empty, we have to ask the opposite question. Can solid matter ever be truly destroyed? To find out, particle accelerators push protons to nearly the speed of light and smash them together. It is humanity's ultimate test of brute force. A proton is built from smaller particles called quarks, which are bound together by the strong nuclear force, the most powerful force in nature. In the modern universe, there is a strict rule governing these building blocks. A quark can never exist alone. When kinetic energy tries to rip a proton apart, it refuses to break. Instead, the energy immediately materializes into a new meson, a quark and antiquark pair. Within nanoseconds, this new mass decays back into energy waves, and the quarks rearrange, keeping the fundamental rules intact. We cannot brute force matter out of existence. The universe literally spawns brand new matter just to protect the integrity of a fundamental particle. Is there any physical loophole that allows for the total destruction of matter? There is exactly one: antimatter. When matter meets its exact antimatter counterpart, they annihilate. It is the only scenario where 100% of a particle's mass converts into pure energy. This calculation shows the scale. Exposing 1 gram of hydrogen to antihydrogen yields $1.81 times 10, $14 joules. This chart illustrates that terrifying reality. That single gram produces the equivalent of 43,000 tons of TNT, dwarfing early atomic weapons. Yet, in practical terms, harnessing this destruction is nearly impossible. It takes immense cutting-edge science just to trap a few dozen antihydrogen atoms for a mere 17 minutes before they disappear. While a mechanism for absolute destruction does exist, the universe naturally quarantines it, making the total erasure of matter virtually impossible on a meaningful scale. When we step back from mass and energy, we have to look at the dimensional architecture of reality itself. For human beings, existence requires dimensions. Time flows because things move from one place to another, and entropy grows because multiple particles interact. But there is an ultimate exception to this rule: the photon. A particle of light has no mass, and in physics, it lacks any subjective reference frame. From its own perspective, a photon experiences zero time and zero distance. The exact moment it is born in a distant star, and the exact moment it hits your eye millions of years later are, to the photon, the exact same instant. We experience a fragile, linear progression of passing time, but the photon exists in a permanent, zero-dimensional state of eternity. From the heavy, friction-filled vacuum of space to the unbreakable glue of the proton to the timeless journey of light, the universe is not an uncertain illusion. It is an indestructible, fiercely protected mechanism governed by absolute physical law.